All right, so we looked at obviously basic derivatives yesterday, and then we did a few with the product rule and the quotient rule before we wrapped up yesterday. So 24 is a little bit different in what they're asking us to do. So basically, they tell us that u and v are functions of x that are differentiable at x equals 2. And then they tell us that u of 2 is equal to 3. And u prime of 2 is equal to negative 4. And then v of 2 is equal to 1. And v prime of 2 is equal to 2. Find the values of the following derivatives at x equals 2. So basically what they're doing is they're going to force us to essentially use the product rule and the quotient rule, but given values, and we're going to write what they're equal to. So like part A is d dx of u times v. So basically we're just doing the product rule and then plugging in numbers. So this would be u v prime plus u prime v. And then we just need to take those numbers that evaluate for those things. So 3 times 2 plus negative 4 times 1. So that's 6 minus 4, which is 2. So that's all you're doing on the ones like this. B, d dx of u over v. So this is u prime v minus u v prime over v squared. Then again, just plug in numbers. So we've got negative 4 times 1 minus 3 times 2 all over 2 squared. Negative 4 minus 6, so negative 10 over 4.
Wouldn't it be 1?
Wait, what?
Because you put v prime.
Oh, yes. I was like, I don't think this is supposed to be a fraction. Yeah, negative 10. I'll put a cookie in the cookie jar.
Making it. How many do we have to get? Or would you like to fill it up?
All my classes together, I think there's 27 cookies.
Okay.
I'm just going to do this up here. I'm going to put... there. Physics doesn't usually get a lot, so... And I mean, it's just you and Cash and then just you, so might as well lump them together. All right. Yes, okay, so that's negative 10. There we go. Okay, C is d dx of v over u. So I'll let you tell me this time what letters to put where. This one's just reversed of the last one, basically.
Oh, okay. So is it v squared on top?
Well, no, it just swapped the letters.
Yeah.
So it's the derivative of the top times the bottom. So it'd be v prime u
Oh, okay.
minus
V prime.
u prime. And then over u squared. The quotient rule's hands down the harder one. So then 2 times 3 minus 1 times negative 4 over 3 squared. Okay, did it right that time. So then I've got 6 plus 4, so 10 over 9 for that one. And then the last part is d dx of 3u minus 2v plus 2uv. So this one, for the first part here, there's nothing, like if it's just being multiplied by a constant, there's no like product rule happening or anything like that. So that's just going to be 3u prime minus 2v prime. Now, this other part over here, the plus 2uv, that's going to be a product rule. But what I would do is I would do the 2 outside and then write my product rule here and then multiply by the 2 once I'm done. So we've got, technically speaking, I've already done the product rule for UV up here.
Yeah.
So if you wanted to, if you've already done something like that, you could also just come down here and insert the value, and like that would be totally fine. We got 2. I mean, obviously, if you're confident you got it right, but most likely you're probably going to do it the exact same way if you did it wrong. So, anyways, but that would allow you then to go ahead and just do that without having to write it again. But if you wanted to, it would just obviously be the same thing we had in part A. So this is 3 times negative 4 minus 2 times 2. Plus 2, or, well, 2 times 2 is 4, so plus 4. So negative 12 minus 4 plus 4, so negative 12. These ones are much nicer. 26 is a multiple choice type question. So we have, which of the following numbers is the slope of the line 3x minus 2y plus 12 equals 0? So I need to, first of all, get y by itself so that I can take the derivative. So we've got negative 2y is equal to negative 3x minus 12. And then divide by negative 2, so y equals 3 halves x plus 6. Now, technically speaking, in this problem, you can find the slope, right? Like, you already know the slope of this line, but taking the derivative will give us the slope of the line. So y prime would be equal to 3 halves, which is going to be your slope. Again, if it was a bigger problem, obviously I would need to do that and then solve it. But since this one was just that, I don't have to do that. And if you were so inclined, it was option 3 from the multiple choice question. So kind of combining everything here to find an equation for the line tangent to the curve at the point. So basically we're going to have to take the derivative and then we'll plug in our value that they give us, find the slope, and then we'll find the equation of the line. So 28 is y equals x to the 4th plus 2 over x squared, and x is equal to negative 1. So I'm going to have a quotient rule here. So y prime is equal to the derivative of the top. What would the derivative of the top be? 4x cubed. And then times the bottom, so that's x squared, minus the top, x to the 4th plus 2, times the derivative of the bottom, which is what? 2x, and then all over x squared squared, or I'm just going to go ahead and write it as x to the 4th. All right, so then I would multiply, obviously, the top. And so I would get 4x to the 5th minus, over here we've got 2x to the 5th minus 4x. I went ahead and did the negative through on both of those things. And then all over x to the 4th. So then to simplify it, I would have 2x to the 5th minus x, or minus 4x over x to the 4th. Obviously at this point I can take away an x from each of these. So I can make this, basically I'm just changing their exponents on them all. So at this point then I would evaluate it for x equal to -1. And when I do that, I would get 2 times -1 to the 4th minus 4 over -1 cubed. So 2 minus 4, -2 over -1. So that would be a +2. So this is the slope of my tangent line here. And then obviously I don't know what the y value is. They didn't give me a y value. So I need to plug in this to here to find the y value. So y equals, sometimes if I remember I do that first, but obviously I forgot this time. -1 to the 4th plus 2 over -1 squared. So that's just 1 plus 2 over 1. So that's just 3. So the point is -1, 3 that I'm using now. And then the point slope form, y minus 3 is equal to 2 times x plus 1. And technically, obviously, this is an okay equation of the line, but to take it to slope-intercept form, because that's how they're going to write it, y equals 2x plus 2 plus 3, so y equals 2x plus 5. So that's my tangent line. Okay. There's going to be some more of that later as like other problems, but for right now the next ones are find dy dx. So basically just what we were doing before. So 30 y equals x to the -4 over 4 minus x to the -3 over 3 plus x to the -2 over 2 minus x to the -1 plus 3. And we're just finding the derivative of this. So the big thing when you have negative exponents and you're taking the derivative is you've got to remember that when you subtract one, like obviously the number's getting smaller, but like the number itself is bigger just with a negative on it. So when I do this, obviously I'm going to take this -4 multiplied out front. Well, the -4 and the 4 on the bottom are going to cancel. It's just going to become negative as a whole. And then x to the -5. For the next one, when I multiply by -3 out front, the negative's going away. 3's cancel. So this is going to be plus x to the -4. Multiply by -2. 2's cancel. I'm left with a negative. X to the -3. And then multiply by -1. I would get positive. So plus x to the -2. And then the derivative of a constant, obviously, just 0. So that part is gone. So you just really have to watch when there's negatives to make sure that you go the correct direction. That tends to be where people get it mixed up. 32. Y equals 2 times the square root of x minus 1 over the square root of x. Pretty sure I said this the other day, but anytime you have like a square root and you're taking the derivative, I would rewrite it as x to the 1/2, or on the second, this part over here, I would write it as x to the negative 1/2 so that I don't have any other weird things happening. And so y equals 2 times x to the 1/2 minus x to the negative 1/2. So what would the derivative of this one be?
Or like x to the negative 1/2.
Yep, because your 2 and your 1/2 cancel. And then what about the second part?
Plus 1/2 x to the negative 1/2. 1.
3 halves.
Yeah, okay.
Why did I just write 3 over 3? 3 halves. Yeah, doing the fractions kind of always throw me for a loop because it's like, especially when you get to like bigger fractions and you have like cube roots and stuff like that, I'm like sitting there like trying to process like, oh, I subtracted this, I need to do this, like. When it's just a square root, it's not as bad, but it still like takes a second to process, like subtracting 1 from a fraction. A lot of times I'll just instantly go in my head to like subtract 2 over 2 instead of subtract 1 because otherwise I'll end up writing it wrong. Okay, the last stuff that we're going to do for today, and then we're going to halt because after this it's going to be word problems applying what we've been doing. So I want you to like have time to like process what we've been doing. But up to this point, we've just taken one derivative. But we can take as many derivatives essentially as is possible until we get down to 0. Like until we get to a constant value that we take the derivative and it's 0. And then obviously like, the derivative of 0 is just 0. So the next problems want us to find the first 4 derivatives of the function. The good news is unless you have something like 30, they get easier every time you take the derivative because things are going to disappear. So 34 is y equals x squared plus x plus 3. So the first derivative, obviously, we've just been writing as y prime. So the first derivative of this would be what?
2x plus 1.
Yep, 2x plus 1. Now, when we do the second derivative, we do it as y double prime, so 2 like little tick mark things, apostrophes, whatever you want to call them. So what would the derivative of this be?
2.
Yep. Then the third derivative, we do 3 tick marks. So y triple prime. Derivative of 2 is
0.
And so then they want us to go all the way to the fourth derivative. So the way we write a fourth derivative is instead of writing like 4 primes, because like I said, we can go on forever and that's going to get to be a lot, is we do a little parentheses where we normally would put the primes and we write a little 4 like that. And then the derivative of 0 is just 0. So basically they could tell us to take the 20th derivative of this and it's still just going to be 0 over and over again. It gets a little excessive once you hit 0. It's kind of like, okay, why am I still doing this?
Yeah.
I am going to do 36. It's not going to be as bad as it's going to look like it could be in just a second. So 36, y equals x plus 1 over x. So obviously we've got a quotient rule here. Now, there is a way that I could kind of shortcut this, but I want to do this part as a quotient rule just for the practice, and then I can show you how I would have shortcut it potentially in a second. So quotient rule, derivative of the top, which is what?
2.
1.
1.
Yeah. 1 times the bottom, so x, and obviously I don't really need to write that, but I don't really need to write the 1, but I am just for the sake of right now. Minus the top, which is x plus 1, times the derivative of the bottom.
1.
Yep. And then over the bottom squared, so x squared. So on top, I've got x and then minus x minus 1 over x squared. So x and negative x cancel. So I'm left with negative 1 over x squared. Now, if I don't do anything about this, I'm going to have to essentially do another quotient rule to keep going, which is going to get really annoying really quick.
Yeah.
What I would do at this point is I would rewrite this as negative x to the negative 2 and make your life easier. So y double prime then would just be the derivative of negative x to the negative 2, which would be what?
2x to the negative 3.
Yep, 2x to the negative 3. Y triple prime would be what?
Negative 6x to the negative 4.
Yep. And the fourth derivative,
24x to the negative 5.
yep. Now, I'm okay with you leaving these like this. Obviously, in ordinary circumstances, we don't want negative exponents. If you are so inclined and you want to rewrite them as 2 over x cubed, or if you're checking your answers, they may rewrite them this way. That's obviously fine. Now, like I told you, up here we did the quotient rule to start with. I didn't really have to do that. If I didn't want to, I could have taken this and said, well, this is x over x plus 1 over x. And I could say, well, that's 1. So I could have gone, well, this is 1 plus x to the negative 1. And I could have gone without ever doing a quotient rule on this particular problem because there was just an x on the bottom. If it was a flipped fraction, I wouldn't have been able to do that, though, because it would have been x plus 1 on the bottom. And you can't split it if it's like that. So I could have shortcut the process and not had to do a product, or not words, quotient rule, but obviously I wanted to just go over a quotient rule again, so that's why I did it that way. But if I had done it that way, then I would have ended up with negative x to the negative 2, which is ultimately what I got when I did that. Like that. So either way works fine. Okay. Pretty much all the problems after this are some form of a word problem, but they're just taking a formula and finding the derivative of that formula. But a lot of them involve quotient rules, so I'm going to go ahead and give you some problems to work on. When do we get out of this class?
I have no idea.
I don't know. 11:34 maybe? This is third period, right? Yeah, 34. Okay. Well, you don't have a ton of time today, but maybe during physics or something, just to go over a few more, at least of the quotient rule problems. If you don't get through all of them today, that's fine. You don't have to do all of them, but just to get familiar with them. Basically 1 through 23 every other odd, and then 25, 27, 29, 31, and 33 as to where we are right now. If you want to go ahead and write them down, 41, 47, and 51 will be the ones that I'm adding after we do the stuff tomorrow. But this way, you'll be able to get started with something and get a feel for some of these quotient rules and stuff like that.